Okay, so we are given the question count number of maximum bitwise OR of subsets. So the problem statement states that find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. So yeah, when you see the word subset, if you have solved a bunch of problems before, your brain might say, let's use recursion, right? Honestly, this kind of intuition doesn't come right away. If you're a beginner, it's not very obvious, and that is completely alright. So now just not jump to the code, let's break down first. Now, what is a subset? A subset simply means we pick some elements from an array, maybe something, maybe nothing, maybe everything. For example, we have 1, 2, 3 in our array. Then the possible subset would be either it can be empty, you take one element, you take 1, 2, you take 1, 3, you take 1, 2, 3. It can be anything, right? In discrete mathematics, you might have studied this as a part of power set. If a set has n elements, then the power set has 2 to the power n subsets, including the empty one. But here's the catch. In our problem, it states that we have to use non-empty subset, right? For example, we have 1, 2, then the possible subsets are 1, 2, and 1, 2, right? So, what's our goal here? We are supposed to find the maximum bitwise OR value across all subsets and then count how many subsets give the maximum OR. Now just pause and ask yourself, how do you usually maximize something? For example, let's just remove this first. For example, you have an array, right? You have this array, 3. If I say you have to tell me the maximum sum of it, then how would you do? You just basically iterate it and then use a variable called sum nums of I, right? And you maximize it with mat.max or any other function, right? So at first, I also thought of doing the same way, right? But here's the catch. Now pause and ask yourself, how you do you maximize something? If you are given an array, right? 2, 3, -1, 5. How would you maximize and get the answer? You would loop through it, right? And keep updating the maximum. We do that in problems like finding maximum sum, maximum element. But here, it's not sum, it's bitwise OR. Now just recall about how bitwise OR works. So if we have 0 and we OR with 0, we get 0. If we have 1 and 0, when we OR with it with 1, then we will get 1. 1 and 1 will get 1. So what we just see that OR just keeps adding more ones to the binary. Suppose we have, let's take this example, right? 2 and 3. 2 would have the binary equivalent as this, and 3 would have this. Now, if we OR it, then 0, 1 would give 1, 1, 1 would give 1, 0, 0, right? So here you can clearly see that a value always lie between this, or it can be up to this, or it doesn't reduce it, right? So in this question, we have to find the maximum, in this question, we have to find the maximum possible bitwise OR of a subset and return the number of different non-empty subset with the maximum bitwise OR, right? So here's a smart observation. If we just OR all elements in the array, we get the maximum possible OR from any subset. Now let's just take 3 and 1. The maximum OR would be 1 and 3, right? It would be 3. That's our target value. So now our goal changes to, let's redefine this question. So this question becomes, how many subsets give OR value equal to target? Now what is our target? Our target is the maximum OR, right? So let's just, suppose we have -1, remove this. Suppose we have 1, 2, 3, right? So we would just loop around it, or in nums. So max OR is equals to num. So this is another way of writing a for loop in Java. So this is our first step, that let's use this color. So our first step would be find maximum all, right? Now, how do we calculate subsets? Uh, we use a recursion to explore all subsets. Suppose we have 1, 2, and 3, right? We start from this index. We either take it or not take it. If we take it, we add to our answer. And if not, we don't add to our answer. So let's make our recursion tree. Now let's take an example from lead code. So we have 3, 2, 1, and 5. So let's write this 3, 2, 1, 5. Now first step, we have to find maximum OR. So just write the binary equivalent of all of these. So we have 3, 0, 0, 1, 1. We have 2, 0, 0, 1, 0. We have 1, 0, 0, 0, 1. We have 5, 1, 0, 1, 0. Right. Let's just all of this would be 1, would be 1, it would be 1. So the OR would be equals to 7, right? So this is our target value, 7. Now let's do the recursion part. We are at index I equals to 0. We have two choices, right? Either we take and include this to our current or we don't. It's just included, right? Our current OR becomes 3, like you have 0 initially at current or, and if you would OR with 3, then you would get 3, right? And then our index moved here. Now here again we have two choices, right? We either take this or not take this. Now just take this first. We have 2 and we have 3, right? If we OR both of them, we would get 3. Let's just, we are taking this. So our current OR is 3 and we are at here. Now again we have two choices, right? We would do this. We would take current OR 3 or 1. It would again be 3, right? Now we have reached at the end, right? Index points here. We again have two choices here. You would either take this or not take this. Current, if you take this, current OR becomes 3 or 5. Now 3 is like this and 5 is like this. We OR both of them, we would get 7, right? So now divide back. 7, our current OR is 7 and we have reached at the end. So our current OR is equals to the maximum OR. So we just have to update a count, right? We have to count the number of maximum bitwise or subset. This is our target basically in this question, right? So we would when we reach at this index, and now our index is out of bound from here, and if current OR, now just write this with other pen, if we reach at the end of our array, and if our current OR is equal to our maximum or what we call a target, then we would simply do a plus plus, right? So we would say current answer plus plus, and we would backtrack. That is, you would just backtrack from here. That's how recursion works basically, right? So again, you can simply explore these parts as well. If we don't take anything, we would reach here. We have current OR is equals to 0 currently. And again, we would have two choices, either to take this index or not take this index. It's completely up to your choice. You can draw this recursion tree all by yourself. So we have concluded that first, use this pen, observations and code. So what we first said is we need to find the maximum OR, right? So we find max OR by simply by iterating and finding. Now, second part, since from the recursion tree we came to a conclusion that whenever our current OR becomes equal to maximum OR, we simply return 1 or increase it by 1, right? So let's do the coding part now. Now let's jump to the coding part, right? So first we calculate the length. Now, what I said that we would first find the maximum OR. So we keep this as 0. We would iterate through it. Max OR is equals to, right? So our step 1 is completed. Now we have to do recursion, right? So now our step 1 is completed. That is, find the maximum OR. This is our target value, right? So our second step is to write recursion. We would make a function, void solve. I usually prefer using void because it's like my format of writing code. You can also use the int or anything which you like. So I start at index I. We have nums. We have int n. We have int max or, and we take a value. When we take a variable, right? Let it be current or. Now our base case. In recursion, the first thing we simply write is the base case. So I told you that whenever we reach at the end of our array, we can check if our current OR becomes equals to max OR. If yes, then we simply increment our answer. So before incrementing our answer, we just use our global variable and initialize it to 0. So the first thing is the base case. If we reach at the end of our array, then we check if max OR is equals to current OR. If yes, then we increment our answer and we return. Now we have to do recursion. Now set we have to take it or not take it. So it comes to here comes to our taking part. We take our index max OR. Now current OR would be current or nums of I. That is the current index, right? That is take it. Next step would be not take anything and move to the next index. Bus, that's it. Let's just return our answer. It's in the sample cases. Okay, so what's the catch? Okay, so we haven't written our function. Solve, we are passing 0. We start from 0, nums, n, we have max OR. We have current or which is initially 0. So we would first use this. It is accepted. Okay, so we have solved this question successfully. And also you can just solve other parts as well. There are multiple questions which are of the similar approach and they are often asked in many interviews, right? And that are